Hello, everyone. This is Keith Jackson, and welcome to the Jack's Math Notebook. Here is our second video as it relates to compound inequalities. And this second example is an and inequality, meaning that this particular compound inequality will have an intersection. And if you know what it is an and compound inequality with an intersection, it would be great to just write this inequality down just like this, in which you have x in the middle, and is going to be greater than a number or less than a number. Just kind of put that first before you even get started with the compound inequality. And here's what we're going to do. We're actually going to use the same inequality for both examples. And you're probably asking why we're going to do that, because there are two methods that you may like. You may like one over the other. So I may as well show you what the two methods have to offer. And so here we go with big example one, in which we have 11 is less than 2x plus 3 less than 21. And you're probably saying, well, why? What do I do with that? Well, what we can do, we can break this compound inequality apart into two regular inequalities. Just as long as we include the number and its attached variable, a number on one side of the inequality and another number on the other side of the inequality. And so in this case, if we just circle this part right here, that will satisfy our first inequality that we can solve. And so now we have 11 is less than 2x plus 3, and then let's form another inequality out of this compound inequality in which we have 2x plus 3 less than 21. Again, we have our number with our variable attached, a regular number, okay, a coefficient on one side of the inequality, and another coefficient on the other side of the inequality. All right, and so let's go ahead and solve this first inequality to find out, well, what is x in this particular case? And we could do that by isolating the variable, which is 2x, right? And so we want to get that all by itself, because you always want to get variables all by themselves so you can find out what's hiding behind that particular variable. In this case, we're going to have to subtract 3 from both sides. And so when we do that, we know that 3 minus 3 is just 0. And 11 minus 3 will give us 8. And so now here's what we have. Right here, we have 8 is less than 2x. So let's just kind of look at that for just a second. We have 8 is less than 2x, and now we're in the position where we can divide by 2 because it is next to the variable x, and we're going to divide by 2 on both sides of this inequality. And when we do that, 2 divided by 2 would just give us 1x, or just x, that you see right here. And 8 divided by 2 will give us 4. And this lets us know that x is greater than 4 on this side. And so if we go back to our little box right here, we know that we have our x right here, and we already know that x is greater than 4. We could put that 4 right there. You see how this little box right here becomes very useful when dealing with compound inequalities? Okay, so let's go ahead and go to the next inequality, in which we have 2x plus 3 is less than 21. And again, we're just going to work with the number that is on the same side as the variable 2x, or I should say the same side as the variable x right here. And so we want to get it all by itself, and we're going to have to subtract 3 from both sides. And so when we do that, now we have 2x is less than 18, because 21 minus 3 will give us an 18. And again, we can divide by 2 on both sides of this inequality, leaving just 1x on this side, or just x, knowing that 18 divided by 2 will give us 9. And so now we know that x is less than 9. And so we could plug in that 9 right here. And so now that we have our solutions to the inequality, we could just go ahead and write it out down here, knowing that x is greater than 4 and less than 9. And we can also graph it. And so let's go ahead and graph the part where it says 4 is less than x. And let's put an open circle right here. And we know that x is to the right of 4, because x is greater than 4. Any number that's greater, we're always going to the right. And at the same time, we know that x is less than 9. And so we're going to put an open circle over the 9 with an arrow going in this direction, knowing that x is to the left of 9 because it is less than 9. And so now we're going to look at the area between the two open circles. That area between the two open circles is known as the intersection. And that lets us know that any number between the two circles will be a solution to this particular compound inequality. And so with that in mind, we could just rewrite these two open circles that you see right here, attach them with a line, knowing that x is between 4 and 9. All right, so we figured this one out. So let's go to big example 2, using the same example, but with a different method this time. And so we have, again, 11 less than 2x plus 3 less than 21. And all we're going to do, we're just going to isolate x between the inequalities. All right, you're going to see this is a real quick way to solve this type of problem. And so what we're going to do right here, the reason why we're going to subtract 3 from all sides is because, right, because 3 is next to that variable right here. It's next to 2x. And because it's next to the variable and we want to isolate the variable every time we deal with equations and inequalities, we're going to have to find that number that's next to it and then work with it. And in this case, we're going to subtract 3 from all sides of this particular compound inequality. And when we do that, we will find that we have 8 is less than 2x less than 18 because we did all our subtraction of 3. And so now all we have to do is divide all the numbers right here in this inequality by 2 because the variable x is next to 2. And so we're just going to divide everything by 2. And so let's go ahead and do this slowly. So we have x, we have 2 divided by 2, which would just give us x right here. 18 divided by 2 will give us 9, and 8 divided by 2 will give us 4. And so as you can see, the answers are the same from here to here. Notice here we subtracted by 3 right here. Just like we did right here, we subtracted by 3 here. And so that was the reason why I wanted to show you both methods, because you can see the similarities as they play themselves out. And so again, we have 4 is less than x, while x is less than 9. And let's just copy this graph right over here, letting us know that x is between 4 and 9. Again, x is greater than 4 and less than 9. You have been given a lot of information. I wouldn't blame you if you need to pause the video to take a look at these two ways of solving a particular compound inequality, or replay this video as many times you need to gain a deeper understanding of this concept. But in the meantime, please comment, share, like, and subscribe to Jack's Math Notebook for more content. Thank you and goodbye.